In this video, our learning target is to learn how to convert from particles to grams and then from grams to particles. And by particles, we mean atoms and molecules. So we're going to be looking at 4 examples. In our first example, you are asked to find how many grams of H2O are there in 2.6 times 10 to the 24 molecules of water. So right now, we're starting at molecules. We need to get to grams. So we are going to be following the blue arrows along the bottom here to go from molecules to grams. So we always start out with what we're given, write that first, and set up your dimensional analysis problem. So the first thing that we need to do is we're going to have 1 mole in the numerator and Avogadro's number in the denominator. And we're going to see why. So this is all just a game of canceling out units. And so if we have molecules on the top and the bottom here, they cancel out. Right now we're left with moles, so we're in this middle step now. And now we'll need to use the molar mass in grams divided by 1 mole. So the molar mass of H2O, or water, we're taking 2 hydrogen atoms, so 1.0079, plus 1 oxygen, 15.999, and our molar mass is 18.0148 grams per mole. So in the denominator, like our flowchart tells us, we have 1 mole, and then our molar mass in grams goes in the numerator. So the 18.0148 grams goes in the numerator. So we are going to be multiplying across the top. So you'll have 2.6 times 10 to the 24th times 1 times the molar mass of water, and then divided by Avogadro's number to get your final answer, which is 78 grams of H2O. So now on to example 2. In example 2, we are starting with atoms. So we're starting right here on the flowchart, and we're asked to find how many grams of copper that there are. So we're going to be ending at grams. We're going to follow the blue arrows along the bottom here to find our final answer. So always start with your given, 4.9 times 10 to the 25th atoms. Set up your dimensional analysis table. So we're going to start with this part of the flowchart. We're going to have Avogadro's number of atoms in the denominator. So 6.02 times 10 to the 23rd atoms. And then over 1 mole. So we can see so far that we've canceled out atoms. We have the same units on the top and the bottom, they cancel. And then next step, we're going to have the molar mass in grams, that's what mmg there stands for, in the numerator divided by 1 mole. So molar mass of copper, look that up on the periodic table, it is 63.546 grams. And then it's over 1 mole. So we can see that the moles, those units cancel out, and we're left with grams. So multiply everything across the top, and then divide by Avogadro's number. One helpful thing is to make sure Avogadro's number is in parentheses when you divide it. So your answer will end up being 5,172 grams. So in our next problem, we're going to start with grams. So we're going to start on the left side of our flowchart, and we're going to end with molecules. So 10.9 grams. Set up your dimensional analysis table. In order to do this conversion, this two-step conversion, we're going to be using or following the red arrows along the top. So our first step is to go from grams to moles using the conversion factor. 1 mole is equal to the molar mass in grams. So in our first example, we already calculated the molar mass of H2O, or water. So I'm not going to do that again. That molar mass was 18.0148 grams. So far you can see that grams of water have canceled out. We're left with moles so far. And now we have one more step to get to molecules. So we're going to use this part of our flowchart. So we're going to have 1 mole in the denominator, and then Avogadro's number will go in the numerator. So we're going to multiply 10.9 times Avogadro's number, hit enter in your calculator, and then divide by the 18.0148. And you will get 3.64 times 10 to the 23rd molecules of H2O. And you can see also that moles have canceled, so that you're left with molecules. So we're going to look at one last example. In this last example, we are starting with grams. So we're starting on the left side here, and we're going to end with atoms. So we're going to follow the red arrows along the top to achieve that. So 3.45 grams. Always start with your given number. Set up your dimensional analysis table. First, we'll have the molar mass of copper in the denominator. So 63.546 grams over 1 mole. So this is the step where we're using the molar mass in grams. That's what mmg stands for there. So far we can see that grams have canceled. We're left with moles right now. Since we want to find atoms, we still need to cancel out moles. So this next step is going to allow us to do that. We're going to place 1 mole in the denominator, and 1 mole is equal to Avogadro's number of atoms. So you're going to multiply 3.45 times Avogadro's number, hit enter in your calculator, and then divide by the molar mass of copper. You can see also that moles have canceled out, and we're going to be left with atoms as our answer. So your final answer is 3.27 times 10 to the 22nd atoms of copper.